So in order for the G's to be less than 30 G's, by what distance should the car crumple in order to save the passenger inside in the event of a car crash? So we have an initial velocity equaling 95 kilometers per hour, and then this is 1,000 meters per kilometer times 1 hour for every 3,600 seconds. And this is going to be equal to 26.389 meters per second. Now, we have an acceleration of negative 30 Gs. So this is negative 30, even negative 30 Gs, that'll be really close to death, only because it's 30 times the acceleration due to gravity that we feel normally. So even with this, it's a pretty low chance of survival. However, anything above 30 Gs is a 0% chance of survival. So we need the acceleration to be at least negative 294 meters per second squared or more. So it can decelerate at a slower pace, so a less negative acceleration. However, any greater than this, and the car is going to stop too quickly, and the person will experience some of the force in the car crash and ultimately die. So we have to say it has to be less than 30. It has to be basically greater than negative 30 Gs. However, we're trying to find how much the car needs to crumple. So we can say that velocity final squared equals velocity initial squared plus 2a times delta x. We know that the final velocity is 0 because this car is coming to a rest. So we can say that delta x is going to be equal to negative velocity initial divided by 2a, and this is going to equal negative 26.389 squared divided by 2 times negative 294, and we have a delta x equaling 1.18 meters. So it will be beneficial if the hood of the car extends a bit past the required length, because if you make the hood of the car longer, it will be able to absorb more impact, and again, it'll come closer to this 1.18 meter mark that it needs to crumple in order for the passenger to survive and experience an acceleration that won't cause them to pass out or die. So the car must crumple at least 1.18 meters. And that's the end of the solution. Thank you for watching.